All right, so now let's talk about predicting products. So a couple of steps that we're going to have to go through and before we can start predicting those products. First thing that you have to take care of is to translate any words that you have into symbols. Sometimes your reaction will already be given to you in that symbol form, but a lot of times it will be in words. So it will be your job to translate those words into chemical symbols. Balance your charges to 0 using subscripts, and be on the lookout for any elements alone in that Brinkelhoff, that diatomic element pattern. All of the elements in this mnemonic have to be either bound to another element or to themselves. Next, we're going to identify our type of reaction. We had 5 types. Synthesis, where 2 things are becoming 1 thing. Decomposition, where 1 item is breaking down into 2 different items. Single replacement, like replaces like, so a single element is going to be cutting in to that dance. Double replacement is our 4th, where 2 compounds do the do-si-do, all of our ions switch. And our last is combustion. Look out for that CHO, C-H and an O. Our third step is to use that pattern to rearrange our ions appropriately. Now be careful. Subscripts present on the left side, the reactants side, can only cross the arrow to the products side if they are part of a polyatomic. Otherwise, thou shalt not pass. So, if you have an ion sheet, be sure to keep it handy and double check subscripts for presence on the ion sheet. Not on the ion sheet, no dice. They don't get to come. Last step is to balance charges of our product compounds to 0 using any appropriate subscripts. So here's where your subscripts get to come in, not from the reactants side. So let's do a couple examples. I had to start this video over, so that's why there's already some writing, but I'll explain it nonetheless. So these are in words, so it's our job to come up with the symbol form. So, beginning, always a good place to begin. So, hydrogen, H, and right off the bat, it is one of my diatomic elements from my Brinkelhoff here. There it is. So, that means my H has to be bound to something else, nothing written here, or itself, hence the H2. Reacts with, this is one of our key phrases that indicates that our 2 elements are being mixed together, so we write a plus sign. My other compound is fluorine. That's another of my diatomic elements. Must be bound to something else, well, there's nothing here, or itself, hence the 2. This will usually be followed by the word yields or to produce, maybe to form. All of these phrases indicate your arrow. There are no equal signs. In chemical equations, this does not equal our products. Instead, they mix to yield. Now, got to come up with our type. So, let's check back on our types here. Let's see which pattern does it fit. Synthesis, 2 things become 1. 1 thing becomes 2. Let's see, I do have 2 things. They're both single elements. Even though I have 2 of them, they're still single elements. So, this is an example of a synthesis reaction. So these 2 things are going to become 1. Now, product side, these 2 things are going to become 1. You might be tempted to carry the 2's across and stick them together, but can't do that. These are not polyatomics. If you have an ion sheet, you could double check. There are no little 2's on that ion sheet. So instead, I'm going to leave the subscripts behind and just combine my 2 elements. Hydrogen takes a +1 charge. Fluorine takes a -1 charge. +1 - 1 equals 0. We're done. Finished, excuse me. Done means you have to stick a fork in it and roast it on the other side. Thank you, Miss Smitherman. Anyway, let's try another one. Start at the beginning as before. Silver chloride, Ag. Cl. Silver is a +1, chloride is a -1, +1 - 1, check. Reacts with, there's our combination, fluorine gas. The F, whoop, there's that diatomic again. We're going to blend these together to yield. Now we have to come up with our type. I have a compound here, single element here. that is going to be our single replacement, where I have a single thing cutting in. So fluorine, when he takes a charge, takes a negative charge. So that means my fluorine will be booting out my chlorine. So when I cross the arrow here, the 2 does not get to come. This is not a polyatomic. So when I combine it with my silver, it's just the F, Ag plus 1, F minus 1, check. Don't need any subscripts. Let's write our Cl off to the side. Chlorine was in our Brinkel Hoff. Cannot be by itself, nothing else to bind it to, so it needs a subscript of a 2. This is your single replacement example. Next example here, off to the races. Magnesium has a 2+, oxide 2-, that one's good. Reacts with tin 4 nitrate. Tin 4 nitrate. Remember to put your polys in parentheses. +4 - 1, ooh, that doesn't equal 0. I need 4 of those nitrates. Now on to our type. I have 2 compounds, completely different, makes this a double replacement. So all of my ions are going to do-si-do. Be extra careful when you cross this arrow with your subscripts. If it's not part of a poly, doesn't get to come. Also, make sure that your positive goes with the other negative. Never put a positive with a positive. Just like opposite poles of a magnet, they would repel. Doesn't end too nicely. So, make sure that you're putting the positive with a different negative. Over here, magnesium is with the oxide, which means on the left, magnesium will be with my only other anion, the nitrate. +2 - 1, ooh, that doesn't equal 0. So I need 2 of my nitrates. Now on to the remainder. I took care of my magnesium, so onto my tin, 4+, already took care of the nitrate. That leaves the oxide, 2-, +4 - 2, ooh, that doesn't equal 0. There we go. As somebody drags something across the floor. Last example here, nickel 3 sulfate, nickel, and he has a 3+ here. Remember, this Roman numeral tells the charge of the previous ion. Sulfate, let's see, +3 - 2, ooh, there we go. Reacts with iron. Here I have a single element who's going to cut in again. That makes this a single replacement reaction. Iron here, my little hint is telling me that once he crosses the arrow, iron is going to take a 2+ charge. Iron has multiple charges, so you would have to be told what charge your ion picks up after it crosses the arrow. Since it's a positive, it has to boot out the other positive. So, iron is going to go with the sulfate. +2 - 2, yay! That leaves the nickel out in the cold. Notice the 2 did not get to come because it is not part of a polyatomic. Nickel by itself, it's also not diatomic, not part of a poly, stays just like that. So there's a couple examples. There will be more as we get into balancing equations in the subsequent videos. So happy predicting and see you next time.